In the last lecture, we saw the condition for a signal to be even signal and also the condition for a signal to be odd signal. If there is a signal xn and after performing the time reversal, the obtained signal x minus n is equal to xn, then we say signal xn is an even signal. And if after performing the time reversal, x minus n is equal to negative of xn, we say the signal is an odd signal. So this is the condition for a signal to be even signal, and this is the condition for a signal to be odd signal. Now in this lecture we will try to calculate the even part and the odd part of a discrete time signal. So let's begin our discussion. All the signals are composed of even and odd parts. Therefore, we can say a discrete time signal xn is equal to its even part, or you can say the even component, and the odd part or the odd component. Now when the signal is purely even, this means the signal satisfies this condition, then the odd part is equal to 0 and xn will be equal to the even part only. Now when signal is an odd signal, this means satisfying this condition, even part is equal to 0 and the signal will be equal to the odd part. But when the signal is neither even nor odd, then you will have non-zero even part and non-zero odd part. Now let's try to calculate the even part and the odd part. Let's say this is equation number 1, and we will now perform the time reversal operation. This means we will replace n by minus n. When we do this, on the left hand side we will have x minus n, and on the right hand side we will have xe minus n plus xo minus n. Here we are performing the time reversal operation on the even part of the signal and the odd part of the signal. And we know if we perform the time reversal operation on the even part or the even signal or the even component, then we are going to get the same signal. This means xe minus n will be equal to xen, and xo minus n according to this will be equal to minus xon. Therefore, in the next step we will have x minus n on the left hand side, and on the right hand side we will have xen minus xon. Let's call this equation number 2. And now we will add equation 1 and equation 2, and after the addition we will have xn plus x minus n on the left hand side, and on the right hand side we will have xen plus xen plus xon minus xon. This means xon and minus xon will be cancelled out, and we will have 2 times xen. From here we can say that the even part or the even component of signal xn is equal to xn plus x minus n divided by 2. So this is what we have as our even component, and using this we can calculate the even component in the questions. Now we will subtract equation 2 from equation 1. This will give us xn minus x minus n, xn minus x minus n, and on the right hand side we will have 2 times xon. From here we can say that the odd component xon will be equal to xn minus x minus n divided by 2. So we have the even component and we have the odd component. Now let's move on to the example. In this example, signal xn is equal to minus 4 minus 5j, 1 plus 2j, 4, and 1 plus 2j is the value of signal xn when n is equal to 0. This makes 4 as the value of xn when n is equal to 1, and minus 4 minus 5j as the value when n is equal to minus 1. And we are required to find even and odd parts of signal xn. This means we need to find xen and xon. So let's move on to the solution of the given example. You can see that to calculate the even part we need xn and we need x minus n, and to calculate the odd part we need xn and x minus n. xn is given in the question, so let's quickly calculate x minus n, and we will have x minus n after performing the time reversal on xn. And we know how to perform the time reversal. Flip this signal about this arrow, or you can simply start from the right and write down all the values till the last value present at the left. This will give us 4, 1 plus 2j, then we have minus 4 minus 5j, and the arrow will be there at the same position. So we have x minus n. Now let's calculate the even component first, which is xen, and for this we need to add xn and x minus n. And we have seen how to perform the addition of two discrete time signals. To add two discrete time signals, we simply add the corresponding samples. Therefore, we will add minus 4 minus 5j and 4. This will give us minus 5j. Then we will add 1 plus 2j and 1 plus 2j. This will give us 2 times 1 plus 2j. And then we will add 4 and minus 4 minus 5j, giving us minus 5j. The arrow will be there at the same position. But you can see that after addition we also need to divide it by 2. So let's divide all the samples by 2. This 2 and 2 will cancel out. So finally we are getting the even part equal to minus 5 by 2j, 1 plus 2j minus 5 by 2j. The calculation of the odd part of the signal xn is homework for you. You need to calculate the odd part following this result, and once you have your answer, post it in comment section. I will end this lecture here. See you in the next one.